So my production process right now is I've got a bunch of 3D printed parts on standby, ready to go, and I always try to keep one running in the background. So 3D print all these. I get a bunch of them ready to go, made out in bulk, and then when all these are done, I go through and I shield all of them with this copper coated paint. Just wire everything up. So I just got a new batch of parts. So there's a bunch of stuff to desolder to get ready for assembly. So this here is the main circuit board that I used to make the hammer. Did a bad job of that one. Try this one. And I plugged it into my computer, and then I upload the code that I want, the code that operates the hammer. I desolder all of these pins, which are made to plug into a breadboard for testing and development. So then once it's pinless and it has its corresponding screen and lid, I wire those together. And then I wire on the microphone. And then I take one of these battery handles. So the handles have the USB-C recharger and the battery inside, and then the ground and the power. And then you plug it all in, and then that's the whole gist. But each of these I make. I CNC these with Will Bizard, Rhino specialist, and we then I go through and I sand all of these up by hand. I assemble everything by hand, wire everything by hand. The only thing that's really done is the general shape is CNC'd. There are two parts. You put locating pins in them, you glue them together, and then the rest of the shaping and the sanding all happens by hand. And then I buff all of them by hand. And then the only other part that's done is with this, done by a machine, is with a 3D printer. Other than that, everything's just done by hand. It's all hand tuned, hand wired. So I am production and quality control for all of the hammers. But I'll walk you through the process of making one. Let's go ahead and finish this one out. Why not? First thing I'm going to do is rehydrate my sponge by sacrificing my water bottle. I just don't want to move to where the Wi-Fi is bad to go refill the sponge in the sink. So, for the sake of keeping the live stream alive, I'll dehydrate myself. All right. So it does get a little bit tedious. Oh, great.
I'll cut it out.
What was that?
I'll cut that out.
Yeah, so this is a little bit tedious, but I grab a hammer handle that's ready to go. This one's close. I'm gonna finish sanding this one up actually real quick with some like sandpaper. I did it most of the way, but I saw a few micro scratches I just want to get out real quick. It's really nice when you sand them by hand because you can't really tell that that's two pieces of wood glued together. And Will does a great job. Before he puts them on the CNC, he cuts them all so that they're book matched. But there really is a lot of craftsmanship involved with that. What you want to do is like grab this. It's always a good idea to twist your wires. That way they shield each other and you can prevent electromagnetic interference. And when you're building an electric guitar, you also want to do this. I recommend shielding the inside of your cavity and also twisting your wires when possible or whenever it makes sense to do so. And that'll shield it from electromagnetic interference. If you do shielding and you forget to ground your shielding, you'll actually just create an antenna and you'll make the EMI even worse. Pull this through. Get that ready to go. And then the first thing I do is I start getting my ground wires and my power wires twisted together. But before that, I want to check with a multimeter to be sure that this battery is actually working. And there we go. About 4 volts. That is correct. So my battery is in fact working. It's always smart to do that when working with electronics so you don't wire the whole thing up and then find out that a part's failed. Then I come in here and I'm going to start by twisting my powers together. This is going to be both input and output. So it's going to be input power to the Arduino and then power out to this being the Arduino. The Arduino is the brain of the operation. And it's both power out to the microphone and the LED screen that we'll be using. Put this together. There we go. Again, twisting wires is good for both keeping things simple, because now I'm essentially working with, as opposed to 1, 2, 3, 4, 5, 6 different wires, I'm only working with 4 wires now, and then I'm going to simplify that even further by taking these ground wires and putting them together. Take these power wires, put them together, and actually I need a little bit more exposed wire. I'm just going to pull that off. The nice thing about these cables, or these little wires that I'm working with, they're the little plastic or rubber insulation is really easy to break apart with your fingers, so I don't need to use wire cutters or anything on this. All right, and then I've got one more ground cable. This is to ground the container. That way this acts like a Faraday box and shields from EMI. rather than behaves like an antenna. So in case there's any dirty power or any how do I explain it? In case there's any inconsistency in the power, I'm going to put this to a different ground input on the Arduino. But the first thing I like to do is wire all the peripheral stuff together before I put in the ground and the power. The power is the very last thing I put in. Just to try to prevent anything from short circuiting, essentially. Okay. So I've done this enough times that I've just got it memorized, but the microphone wire goes into pin 26 on the Arduino. And what's really cool about all this is with the advent of AI, the learning curve for this stuff has been shortened significantly. It's a lot less daunting to get into this sort of work. So if there's any sort of creative ideas for Luther retools, or I've had a few ideas like having a system of automatically closing blast gates or something for your dust collection system, or automatically turning on dust collection when you enter or exit a room, just little things like that that are time savers or you think might be valuable to other luthiers. The learning curve to make those tools has been reduced significantly. So if you have an idea, you can acquire with a combination of the internet, a little bit of self-reading, and AI, ChatGPT, and you can figure out how to build these things with relative ease. And it'll even go as far as to help you through the coding process if you don't know how to code. Most of this, I just coded in English by having a conversation with ChatGPT, and this is a pretty complicated code. So any little idea you have, if you want to get into building a website for yourself or get into doing what I'm doing here, it's really not that difficult. All right, I'm just going to double check that that is indeed pin 26. It's labeled on the other side, and I did get it right. So there's pin 26 there. I have a lot of solder on there, though. It's a loose joint. That's not going to cut it. Come in here and add a little bit of solder. All right. And then we're going to plug in the screen here pretty shortly. I'm just going to add some solder to some of these pinouts that I know I'm going to need later. Okay. So this yellow one here is a cable going to the screen. And I put that in this pin, the third one down on the right side. Try to do really clean work, because if anything goes wrong and I have to diagnose an issue and the entirety of this build was sloppy, well, then I would have a lot of things to go through in the diagnostic process in order to figure out what's wrong. But if I do everything clean and there are minimal mistakes, I have much less variables that could be potentially contributing to the problem that I might be having. And I also find you reduce the probability that you even will have a problem if you just do quality work to begin with. And that is a good lesson in luthery, as it is in life. And that's a claim Brian's always made when it comes to wood rating, which is another thing that this device can really help with. But if you just use quality materials going in, the probability that you'll build a consistent instrument and build an instrument that you're pleased with going out is increases significantly. I think his short form of that is quality in leads to quality out. And then this green one goes into this 6th pin. Everything leading up to this build process is pretty fast and not very tedious. It's this last part of wiring it all up and hand tuning it and getting the code uploaded that it's a little more tedious. Okay, these wires certainly need to be tinned first. And so, does this one? It'll help keep my twisted wires together and help them have a better join. Okay, there's one other ground cable I want to get first, just while I'm over here. Again, this is the ground where I'm grounding the entire box. I'm increasing the grounding plane. I'm turning this box into what you call a Faraday box, which is essentially the opposite of an antenna. Again, this is a strategy often used in electric guitar building. Shield the whole cavity, then ground it. Having trouble with this going in and conducting heat, so I'm going to tin this wire too. I like my wires to go all the way through the pin. It increases its structural stability. And then actually, when I confirm that everything's working, I will go through and solder, or not solder, sorry. I'll take some super glue and I will glue all these solder joints so that they're really stable. Okay. There we go, that's it. It's always satisfying when you get it to click into place. And then I'll come over here. And we'll put this in. Got one last one to do. The next thing I do, I'm gonna erase the blade. Old one here. And I want to prevent those guys from acting like antennas, so I trim all of them back. Always correct. Plug it in and see if it works. And it does. So I plug it in from the charger end there. And that certainly works. So I have the light there, the power light indicating that the Arduino is in fact on. And I unplug it and the battery is still powering it. So this hammer is looking good so far. Now, obviously nothing's working. The screen isn't showing up yet, but we have yet to do the most beautiful part here, which is upload the computer code to the Arduino. So you plug directly into the onboard USB-C. And I'm going to open up my computer code here. Most of which I will obscure because it is my, you can shoot that. Okay. But the code is about 175 lines of code. When I come in here and I click upload, it'll detect this USB and then it'll upload my code. And it'll tell you when it's done. Said leaving, hard resetting via the reset pin. So that means this is good to go. And what we will probably find is that this hammer is functional. And there we go. It's alive. And the other thing I do is I take my iPad, which almost always has a tone generator permanently open. And I confirm that its tuning is correct. Do that by gently lifting everything over to here. And I play a pure tone. The hammer predicts 494 hertz, and it was at 493 hertz. 793, the hammer predicts 794. The hammer predicts not 510, the iPad says 509. Excuse me, getting a phone call here. Let's see about this one. Hammer says 291, iPad says 291. Hammer says 947, iPad says 946. $389, right around 388, so it's really, really accurate. So I'm good with that, and we'll do some more testing on it. One of the other things I got to do is I got to confirm that this whole shielding scheme is working, but the first thing is I know that the wiring on this is correct. So I'm going to strengthen all of my solder joints with a little bit of CA glue. Yeah. And very carefully get a little bit of glue on there, and a little bit of glue here. I'm going to do this to all my joints because I never want this thing to fall apart. And again, you know, I only want to do this after I confirm it works, because I would hate to have to resolder through the CA glue. It's possible, but it is incredibly fumy, and it will make you sick. Gotta wear a spray mask, or at the very least a dust mask if you're going to attempt that. Now there is glue out there that's specifically made to strengthen solder joints, but I found that the CA glue that we just have floating around in the business already works beautifully. And again, in a pinch, if I ever did have to disconnect these, the glue will melt the second the gun makes contact with it, my soldering pen rather. Sure. Let's got one more to do. This guy I kind of just cake and glue, because it'll also help adhere my microphone in place and prevent that guy from moving around. And then the last ones you got to reinforce are the ones by the screen. So I do a little bit of glue. Down there. I do the whistle test periodically to make sure it's still functioning as I do this. Now the next big thing to test is that my shielding is actually properly working. And I'll know if it's not working if I put this thing in here and I get a frequency that's between 170 and 185 hertz. That's some electric interference coming from the USB-C power regulator down here. It has a switch in there, and a voltage regulator that protects this thing from getting overcharged or receiving too much voltage. It'll protect everything. That way you can charge it with really any USB-C laying around. And in order for this to work, or while it's functioning, it'll produce a little bit of a hum, a little bit of electromagnetic interference. And that frequency range is again between 170 and 185. So if I close this thing up and it's behaving like an antenna, I should start seeing frequencies whenever I try to get an output from the hammer and within that range. If I don't see any of those frequencies popping up, that means it's properly shielded. If I do see those frequencies popping up, it's improperly shielded and something needs to be addressed. So before I call this good and I completely box it up and get everything glued together, I'm going to prepare this thing to be smushed into the case. And I'm going to run a few more tests to make sure that that frequency, that aforementioned frequency, doesn't pop up. And again, if it doesn't pop up, then I'm going to go ahead and call it good, and then we're going to glue everything together. I add a little bit of tape here, just because I don't want these pins to make contact with, like if I stuff this in here, I don't want any of those pins to make contact with the metal pins on the screen. But just kind of prepping this thing to be smushed in a case. And the cables themselves are pretty strong. I mentioned earlier that the sleeves, the rubber sleeves that are insulating everything are fairly fragile, but the wires themselves hold up pretty well. I've never had the wire break on me before. The only thing I've ever had happen is the solder joints failing, but now that I've CA glued all of them, I found that the hammer is actually really stable. You can bang it around as much as you want, and do what it was intended to do without having the fear of something falling apart on you or a solder joint coming loose or something. Let me get that in there, protect it. And then I like to do one more piece of tape over that. So yeah, this is all entirely done by hand, which I actually think is pretty cool that we're able to do that. I want to make sure that that doesn't make contact with the shielding. I'm going to put a little bit of tape over there too. Gently try to tuck these wires away. Get that crammed in there. And microphone goes down there. And still reading 90 hertz, which is a good sign, but if I tap this, if I ever get a frequency that pops up at around 170 to 185, I know that I've got an EMI problem. And so far it's looking great. There's another test I do, and that's I call it a short burst test, which is I very quickly play this pure sinusoidal wave. Make sure this is turned up all the way. Okay, so 389. I'm gonna do a higher frequency here. So that's good. When it's just a short burst and it can't catch it, it says retap because there wasn't enough information there. If I let it drone out for a little bit longer, it says the proper frequency. And the fact that it says retap when it's uncertain instead of reading a default EMI reading means that this hammer is indeed functioning very well. So I'm happy with this. I'm just about ready to glue everything together. Before I do that, I'm actually going to do a little bit more sanding on this, finish sanding on this. So I'm very gently going to pull the handle out of the pocket very gently. Just like so. Lay everything down nicely. Plug my iPad, which at this point is just used for tone generation, back into the station. And I'm going to sand this up to 400 grit, then I'm going to buff it. And then we're going to start gluing everything together. The USB-C is clear of anything. Now I'm going to install this cap on the end of it. That's in this battery. This battery I recycled from an old hammer that I was unhappy with. It didn't meet my quality standards, so I was still able to salvage the battery from it. I still resanded it up in grit. It had some gaps in it, so I dust filled the gaps to try to make them seamless again. I'm going to do a little more dust fills up there, but it's really important to me that all of these hammers go out with the highest quality. All right, so I come over here and grab one of my 3D printed caps, which I always just have ready to go. And again, I just always keep the 3D printer running. And I come over here and I do a test fit first to make sure everything's going into place nicely, which I'm glad I did. Looks like it's still slightly off. Get that corrected. And let's see. It's not wanting to go in. There we go. So we are pro. There we are. Okay. I just click that right into place. And then we go, a nice snug fit. And before I do that, I'm going to check one last time the hammer's working. It is. I almost whistled a perfect A. I was just 8 hertz off. I'm gonna come over here and plug this in. Saw frequency around 180 and it scared me. I'll try it with the battery plugged in here. See if it gives me any EMI. It's just detecting the very low frequency of the finger tapping. So it is doing its job. There must have actually been a frequency at 180, which is great. It's really important that we make sure precision tools like this are actually reading accurately and doing what they say they're going to do. So I'm going to come over here. I'm going to put some CA glue in the bottom of this. And I put a little bit in the rim there. Just a little bit. I'll let all this kind of flow down so I don't get any glue squeeze out. Feel good about that. And no glue squeeze out. That's great. And then we'll let the fumes of the accelerator get in there and get that thing stabilized. Now, I've got a nice little USB-C charging port, the nice 3D printed cap on it, and we'll do another test to make sure that this thing charges. And it is, it's charging. I can see a tiny little red dim light in there from the charging board to confirm that it charges, but when these hammers are done, they don't even need a charging indicator. All you do is you just plug them in for a few minutes and it'll have enough charge to do the job. If you want a full charge, plug it in for about an hour and a half, and that'll bring it fully up to capacity. And to turn it on, you just simply tap things with it. It automatically turns off on its own. When it detects a loud sound, it'll turn on, and it'll tell you the frequency of that sound. So that's all it does. Now it's really ready to be assembled. I'm going to check for that EMI one more time. So if I make a really quick sound and didn't get enough data, it'll ask for a retap. If I make my sound a little longer, it's some of the frequency. So that's good. It's not misreading. Let's give me another 180. Might have a little bit of EMI. We'll see. It's fully contained what it does here. There's one other area that I can actually shield off here. This piece of tape here. I stick this over here. Just over that opening. Like so. And one other thing I can do to ensure that I'm actually getting maximum contact from my grounding surface is stick a little bit of tape on there. That way that tape makes contact with the wall. And I know that I'm properly grounded. It's working. Yeah, it's working really well. I actually think that 180 hertz was the genuine sound of the carbon fiber clinking up against itself. All right. So we are good. This definitely passes the test. It's reading all the right frequencies. We can do one more frequency test with the iPad to make sure it's still reading accurately before I actually box this thing up. Frequency not low. Let's see, yep, 275. Yep. $6G6, yep. 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 There we go. Okay. This is definitely good. So now all I have to do to this is buff the handle. I take a handle of the buffing wheel. Make sure it's got a really nice shine to it. And then I glue this together. I like to scrape off that gold perimeter shielding and clean up any gold overspray that I got from that and glue on the handle. And that's it. Other than that, this hammer's ready to go. But that'll be all for tonight's live stream. I'll see you guys again soon.